So Chapter 10 takes the materials developed in Chapters 3 through 9 and applies them to the question of how rigorous is the research that we conduct in typical business research, and how might we go about improving it. So what we'll be covering in this chapter summary is first, what is rigor? Because this is a term that's not so easily defined. We'll then talk about some of the limitations of theory, particularly as it deals with complex environments. We'll look at some of the statistical evidence that we often rely heavily on in management research and ask the question of whether it's really as valid as we think it is. We'll talk a little bit about the processes that we use for quality control in our research. And finally, we will look at this as a real dilemma and ask the question, can business research as it's currently conducted really continue indefinitely, or do we really need a new paradigm for our research? One of the surprising things I found about rigor is that it really is not well defined almost anywhere. And I searched for quite a while before I found a definition that I was comfortable with, and this was actually in a journal related to nursing. But I'll read this statement, which I think kind of captures what I think we really mean by rigor. By scientific rigor, we refer to the process of systematically studying a phenomenon using an appropriate design and methods for the problem, and often including the development or testing of theory. It is more than this, however, involving an attitude of curiosity about the way the world works, with the attendant risks of having one's hypotheses proven incorrect. So what are the key elements that we might distill from this definition? The first is systematic. If something is going to be rigorous, it needs to involve a systematic study. You can't just narrow your field of focus to the areas where you think that your particular ideas are going to be validated. If you want to make a rigorous statement across a whole landscape, you need to be systematic in studying the landscape. There needs to be an appropriate design. And what I would argue is that certain problems in physics demand a very different design from similar problems in, say, behavioral research. Finally, it needs to be challenging. It's often possible to find statistical significance in answering questions that nobody's asking because they already know the answer. If you really want your research to be rigorous, you have to choose problems that are challenging, problems where the answer is not immediately obvious. So a lot of times when we're developing theory, what we're interested in is finding things that make some variable better. Obviously, if you care about a particular variable and your theory tells you do X and it will make things better, that's going to be a theory that's of interest to you. But when we're dealing with rugged landscapes, we have to think carefully about that type of theory, because on a rugged landscape we can say two important things. The first is that accepting attributes that are actually decomposable, which is to say they act on their own, you will nearly always be able to find some region of the landscape where a particular characteristic leads to fitness. Which is to say, if you're looking for an answer, you'll almost always be able to find somewhere where that answer is true. By the same token, however, if you research a rugged landscape long enough, you'll almost always be able to find examples where a particular phenomenon is not true, and you also will be able to find areas of the landscape where some unrecognized variable suddenly contributes to fitness, because that is what ruggedness does for you. And essentially what that says is, if you apply the wrong research method, you can almost always come up with any results you want, which of course is not rigorous. A glaring defect of theory is that it isn't really able to accommodate black swans. Take the example of a casino used by Nassim Taleb in The Black Swan. The most obvious threat to a casino is the notion of somebody breaking the house. But because gambling is a highly probabilistic exercise, you can essentially control that probability and bring it down to effectively zero by controlling the size of bets and by having enough bettors. Now, a threat that's a little harder to address is that of security. So if you take a look at casinos, a lot of the stuff you see relates to security, the cameras, the pit bosses wandering around, and so forth. And they've been very effective at eliminating security threats. There's very, very little theft from casinos. Does that mean the casinos have eliminated all the risks? No. As a matter of fact, there was one casino that was nearly put out of business 4 times by threats that neither fit the security or the probabilistic threat models at all. What really put it out of business, or nearly put it out of business, was a tiger mauling one of the performers in the Siegfried and Roy show. That was a $100 million hit. A disgruntled contractor was planning to blow up the casino. Fortunately, that plot was foiled. An employee didn't file the proper IRS forms, which could have caused the casino to lose its gaming license, which would have put it out of business. And the daughter of one of the owners was kidnapped, and the owner dipped into the till in order to pay the ransom. And once again, this could have put the casino out of business through loss of its gaming license. The point is that none of these 4 threats came from within the system that they were looking for. That's what makes them black swans. And what Taleb argues is that black swans and gray swans have a huge impact on real-world phenomena. So having a theory that does not accommodate black swans isn't a very useful theory because it won't be very helpful in modeling real-world behaviors. Another problem with theory in complex systems is there isn't an awful lot of evidence that experts are really good at dealing with them. In fact, experts are sometimes worse than the most naive individuals. Dubont examined how well economics predicted indices for over 5,000 predictions from expert analysts. And essentially what the results found were that the group did much worse than just predicting the market would rise every period. It did significantly worse than that prediction because we had so many predictions. Even a small difference is big. And the naive observer of history, knowing the market rises more often than it falls, could have beaten the experts substantially simply by always predicting that it would rise. Ziliak and McCloskey wrote a wonderful book called The Cult of Statistical Significance. And the main thrust of that book is that the 5% significance level, which has become kind of the gold standard of empirical evidence, really isn't that meaningful. If 5% statistical significance is all you're looking for, it doesn't really matter whether the effect is large enough to have any impact. Also, if 5% significance is all you're looking for, you sometimes tend to ignore the important things. I love this quote from the fellow who actually invented students' t-test, which is where the significance testing began. And he was a brewer working for Guinness Breweries, and he didn't really think statistical significance was that important. What he argues is if a model tells you that in 19 cases out of 20 something works, then the really interesting case is the 20th, and you want to know what causes that case not to work, and you want your error to be small. You don't care about the statistical significance. What you care is about what can be applied to practice. As I became more interested in statistical significance and the impact of complexity, one of the things that I started to do was simulate complex landscapes using a biological model developed by Stuart Kaufman, and throwing agents randomly out on the landscape and then allowing them to migrate towards fitness. And the question was, if you start allowing these agents to migrate through fitness and then apply the research techniques that we would normally apply, such as multiple regression, to what types of patterns just develop at random. Well, it turns out that even with random landscapes, what you see is extraordinary patterns developing. So that if you allow agents on such a landscape to take even one step in the direction of fitness, what happens is if you start with 100 agents and a relatively complex landscape, you will find that very quickly, if you do multiple regression, you start to get a lot of statistical significances. And I did thousands of these simulations. Here's the results of, I think, 10 of them. And what you see is that practically every time you do this experiment, you get some statistical significances. The problem is the significances don't really mean anything because it's a complex landscape. There are lots of interactions, so it really doesn't make sense to believe that individual variables will act on their own. The problem is, using our statistical tests, it looks as if they're acting on our own, but it turns out that this knowledge is not very useful. In fact, in a perfectly random environment, when all your agents have moved to fitness peaks, you're going to see a bunch of statistical significances if you do a multiple regression of that landscape. But it will be entirely meaningless because if everyone's on a peak, then anytime anyone changes based upon your recommendation, their fitness will go down. Because in such a landscape, incremental changes from a peak always lead to a decline in fitness. So you may see there are a lot of significant variables, but they don't mean what you would expect them to mean. They aren't recommendations of things that you should do. And this is one of the problems of dealing with complex landscapes. And it's why it's so important what we talked about in Chapter 4 about if you believe business landscapes are complex, then it really isn't that rigorous to apply these techniques which start from the very beginning assumption to imagine that they are not complex and that we can decompose the effects of every variable. Another problem that our desire to create theory and generalizable results sometimes leads to is that it produces what I refer to as powder puff hypotheses, which is to say hypotheses that are so likely to be true that nobody really cares about them. For example, early studies in the field of decision support systems found that the contributors to decision support system success were as follows: top management support, a clear need felt by the client, an immediate visible problem to work on, and early commitment by the user and conscious staff involvement. The question I would ask is, in what possible universe, and a well-institutionalized ORMS or MIS group, in what possible universe would these things not increase the likelihood that a system would be accepted? Now, one of the arguments in favor of the rigor of our research is the quality control process that we put it through. And peer review in particular is the gold standard for ensuring that what gets published is reasonably true. The problem is peer review is not nearly as reliable as we might think it was. And there's a very famous study done by Sessi and Peters who resubmitted 13 recently published papers to psychology journals. And these were top journals. So what happened? Well, first, only 3 of the 13 were identified as duplicates. That calls into question how effective peer review was at finding problems. 9 of the 10 manuscripts that were not detected as duplicates were recommended for rejection resoundingly. In other words, these recently published articles that had not been rejected the first time around, 9 out of 10 of them were rejected the second, which suggests that the process was not that reliable. Of the 20 reviewers recommending rejection, not one suggested that it might be possible to rewrite the manuscript to make it suitable for publication. A rather interesting thing about this study, by the way, is after it was published, there was a great deal of condemnation, not of the research, but of Sessi and Peters for having conducted such a study, which they argued was unethical. The authors actually estimated in their subsequent piece that in order for the original 10 manuscripts to have published, they would have needed at least 16 favorable reviews as opposed to the 2 favorable reviews that they were actually received. So this really indicates that the peer review is not the kind of reliable process that we sometimes presume it to be. So the Ceci and Peters study was in psychology. So what about more business-related fields? Well, William Starbuck was the editor-in-chief of Administrative Science Quarterly, which is one of the top journals in the management field. And what he did was he looked at a bunch of journals and saw how much the reviewers agreed with each other. That's the inter-rater review correlation. And he did this in a number of different fields. What he found for his own journal was that the coefficient was 0.12, which is on a scale of 0, no correlation, to 1, complete correlation. As a practical matter, this is a meaningless correlation in terms of practical terms, even though it was statistically significant. He then conducted a simulation trying to figure out what the likelihood or what the degree to which articles accepted had been a matter of chance, and for the journals that he looked at, it was between 29% and 77%. So that in some journals, the odds of the paper having been rejected were like 3 to 1 had he brought the paper in again. Basically, what this suggests is that this tremendous weight we place upon peer review is not justified by the actual evidence. The problem is we haven't found a better system to use, which is why we continue to use it. Another source of information on our quality control deals with replications. In many of the hard sciences, findings are not taken seriously until a different researcher has replicated them in his or her own lab. Well, if we take a look at business, the story is nowhere near as clear. Specifically, very little research is replicated. For example, in finance, maybe 5.3% of the papers were replications with extensions, which is to say they replicated the original with some additional stuff. 60% of those conflicted with the early results, with only 20% providing full confirmation. In marketing, only 0.8% were replications with extensions, a tiny number, and 60% of those also conflicted with the early results, with 25% giving full confirmation. In other fields, 6% of the studies were replications. In accounting, 50% of the results conflicted. Economics, 61%. Only management bucked the trend with 14%, but part of the reason for that is in Hubbard's methodology, if you got any of the hypotheses confirmed, it was treated as a confirmation. Well, management papers typically have so many hypotheses that just by random chance, you're bound to get some confirmation. But less than half of all the replications fully supported the results of the original paper. What this basically says is that when we try to replicate our research in a different context, we do not succeed, which may be one of the reasons that nearly all of our top journals refuse to publish replications. So what all this leads to is what I refer to as the business research quandary. And what I mean by this is that we define rigor in terms of adherence to our accepted research protocols, essentially the paradigms that we follow. And we've tied ourselves to the notion that the gold standard is a 5% significance test. What I would argue is that this is not necessarily real rigor, but it is what we have come to accept as rigor. When we talk about fitness, what we're trying to achieve, what we value is theory production. We're looking for generalizable results, and we don't really give a lot of value to in-depth observations. And while this might make sense in some contexts, in a complex landscape, this notion of generalizable theory is much, much harder to justify. Finally, as I mentioned in previous lectures, Fitness is not something that you can observe directly. You have to estimate it. And so the way we try to estimate our fitness immediately is by peer review of the articles we submit. And we've already seen that peer review has some significant problems when you look at the kind of agreement you get between peers. In the short term, we measure fitness based on the quality, or more specifically the ranking of the journal outlet that something is published in. And in the long term, we look at how often an article is cited. Well, all of these things represent the informing activities for other academics. They do not necessarily represent the informing of practice, who are the actual individuals who could put our ideas into action. And this creates a fundamental challenge for business research. Now, of course, the existing business research paradigm is not the only way that we can envision research. And so let us think about an alternative paradigm where we define rigor in terms of systematic, well-designed, and challenging research, recognizing the realities of context, including the complexity of the underlying landscape. Notice this is how I defined rigor at the beginning of this particular chapter. When we talk about fitness, we ask, can the research be applied to specific situations? Can appropriate measures be applied in the research? Are we looking at the right things? And does the research have practical significance? Virtually none of these criteria are used in evaluating academic research, but in other types of research, these criteria would make sense. It's really an issue of how useful the research would be. Finally, in terms of measurement, our immediate measurement is, does reading the research lead to useful insights? And in the long run, can those insights be shared? And this is a research paradigm which really cannot be conducted by academics themselves. Rather, it can be conducted by individuals who are both trained in research methods and work in practice, or by academic researchers and practitioners working in partnership to ensure that the research has impact. And I believe that this is the fundamental change that is required if we really want our research to inform business.